Alright, so this is the beginning. Got the battery, some big heavy cable on it. These are 2/0 cable, and you can see it's about, maybe, it's bigger than that side of my thumb, about the same. It's big as my thumbnail. Anyway, so we got those coming out of the battery. That's a fuse on the positive side, and a switch on the positive side. That's the same kind of switch they use on boats. It's on at the moment, so the battery monitor, which connects there on the negative side, it's got the one little wire running to the distributor for a little power, and then the cord runs up to the monitor. The monitor, I just goofed with it. The battery's not full. It says 3.2 volts, 300 amp hours, 100%. But you need to charge it up fully and then reset the monitor to know what 100% is. So I'll be doing that as soon as I get this bad boy, the inverter charger, going. That will have AC out and AC in where the shore power comes in, if you happen to have shore power. And right now, I've just got the cables through the hole. They're not connected yet. But the battery will connect to those two at the bottom. Then all the AC stuff plugs in here, in and out. So this is one little doodad I decided to get, even though it's fairly pricey. But it's basically a positive and negative bus bar. So the top rail is the positive bus bar, the bottom rail is the negative bus bar. And you can see that it has room here for 4 different inputs. One here, 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 and here. The cables stack on top of each other. So the black and white, black comes in below, red comes in on top. Then a fuse goes across here. So every one of these 4 spots will have a different size fuse depending on what you're going to be running. Has to be a big fuse for the inverter because it's a 3,000 watt inverter. Even though I won't be able to actually use 3,000 watts, it'll have to probably be a 200 or 250 amp breaker. The one I have in here for the total is 300 amps. But the battery can only put out 200 amps at a time, so that fuse is 150%, which is okay, I guess. The wire should go up plenty for that. So I'll need a fuse for all 4 of these. But this is where the inverter charger is coming out. So when it's charging, it'll actually be putting power back in to the battery. And when it's running the inverter, it'll be sucking power out. And it could be a lot of power, so it's got to be heavy gauge. Now the rest of this stuff is going to be a much smaller gauge wire because it won't be pulling that much DC amps. So one is going to go to the solar charge controller, this thing. So the panels will be putting power into here. This will be going into there to provide solar charging. The next one over is going to be for my DC to DC charger, which will be coming from the car alternator truck. And so that will provide charging when the truck's running. And then the last one is going to go out to the DC fuse panel, which is down there. It's an AC and DC fuse panel. So out of that inverter with the AC will also go into that panel. And I'll have room for all kinds of DC circuits. I'm probably going to only have one AC circuit. I'm going to get a 30 amp shore power connection, but I don't know if I'll be using that much AC. If I do, I've got 2 15 amp breakers and a 30 amp main for that fuse panel. So it will give me 2 different AC circuits. I might have one dedicated to maybe a heater or even an air conditioner, and the other one just for house plug-ins. But that's the start, and just so you know, it's actually working. I'll turn off the switch. Boom. Off. It works. So, more to come. It's pretty nice. Had to crimp all the wires myself because, you know, you buy the bulk wire. So there's a hydraulic crimper. Pretty neat. Worked pretty well. Tends to get a little crease on the side of the crimp, so shrink wrapped everything, or heat shrink on all the connections. Looks pretty good. Those are copper bars in between the switch and the battery monitor shunt to the Lynx distributor, which is what this thing's called. So it's pretty cool. I think it's going to be good. I'm going to try and hook up the inverter charger next so I can charge up this battery and do some load tests and make sure the battery's good. So we'll see you next time. All the negatives down here and they're stacked on top of each other, lower and upper. In between the actual cable and the bus bar is a fuse. The inverter charger will take AC power, which is what I have here, like shore power. Comes in, and if there's shore power, then it will not only provide AC out, which is this wire, and I have a little heater plugged in. I've got it on the 750 watt setting. Yeah. And that is running. It's on, if you can't notice. And at the same time, it provides the AC output and sends power back through the cables into the battery. So, as soon as I get completely charged, then I'll reset the meter so it knows what 100% is. But shows everything's working. Charging the battery, charging the load, 106 volts. Charge lights flashing, AC inverter lights on, no fault. So today, did a little more goofing. Got the MPPT charge controller hooked up to the distributor. So that plugged into there. The meter says we're pulling 900 watts. That's because the inverter has efficiency losses. So instead of 750 watts, we're pulling almost 900. Then, if I flip it to 1500, the inverter fan kicked on just now. I'm pulling almost 150 watt or 150 amps. Voltage is staying steady. Says I've got 298 amp hours. At this current draw, it says I'm gonna have, it's going down. It says, it should say I've got about 2 hours. Because if I'm pulling 150 amps and I've got 300 amps, it should say about 2 hours. You can see it says minus 147 amps. Well, come over here, hook up our shore power, and the inverter charger says, oh, we have shore power. Boom. Now it's charging the battery, and it shows a load there about half capacity. It's actually a lot closer to full capacity for me because I can't get the 3,000 watts out of that inverter at this point. But then you see here, it says I'm charging plus 60 amps. But anyway, next step is maybe the breaker panel for AC and DC distribution. That's that sucker over there. And I need DC-DC charger for the alternator charging. But it's looking pretty good. Gotta go wrap up, watch some football. Hope the Rams won.